Conditions for the existence of life on exoplanets. There are three main conditions for the potential existence of life on exoplanets. Presence of water. Water is essential for the existence of life as we know it. All life on Earth requires liquid water as a fundamental component and for various biochemical processes. Therefore, for life to potentially exist on an exoplanet, there must be liquid water, either on the planet's surface or in its atmosphere. Liquid water on the surface can form bodies such as lakes, seas, and oceans, while its presence in the atmosphere can lead to clouds and rainfall. Suitable temperature. Life can thrive within a specific temperature range. Earth's average surface temperature, for example, is approximately 15 degrees Celsius, which has allowed for the evolution of diverse life forms. To support life, exoplanets should maintain a suitable temperature range. Extreme heat can lead to the breakdown of life's essential molecules, while extreme cold can cause organisms to freeze. Energy supply. Life requires a source of energy for survival and growth. On Earth, sunlight serves as the primary energy source. Sunlight is harnessed through photosynthesis by plants and serves as the basis for energy in the food chain. Exoplanets hosting potential life must have an energy source, which could include sunlight or alternative sources such as geothermal activity or the decay of radioactive materials. Additional conditions. In addition to the primary conditions mentioned above, several other factors are crucial for the existence of life on exoplanets. Geology. A diverse geological environment can provide essential minerals and organic materials necessary for life's composition and structure. Atmosphere. An atmosphere is vital for protecting life from external hazards, regulating temperature, and providing oxygen for respiration. Magnetic field. A planet's magnetic field shields it from solar winds and protects the atmosphere, preventing the loss of gases essential for life. Scientists are actively searching for exoplanets that meet these criteria. While some exoplanets have been discovered that partially meet these conditions, no exoplanet with conditions identical to Earth has been found yet. Conditions for the existence of life on exoplanets. The potential conditions for life to exist on exoplanets can be broadly categorized into the following. Presence of water. Water is a fundamental requirement for all known life forms on Earth. Without water, the emergence of life is highly improbable. Therefore, for life to potentially thrive on exoplanets, the presence of at least liquid water is essential. Suitable temperature. Life can only survive within a certain temperature range. Extreme cold or extreme heat can make life unsustainable. Hence, the surface temperature of exoplanets should be maintained within the range of -10 to 100 degrees Celsius. Presence of an atmosphere. An atmosphere is crucial for shielding a planet's surface and providing oxygen for respiration, which is vital for most life forms. Therefore, exoplanets should possess an atmosphere at a level similar to Earth's. Presence of essential elements. Life, as we know it, is composed of essential elements such as carbon, hydrogen, oxygen, nitrogen, and phosphorus. Thus, these elements need to be sufficiently present on exoplanets. Scientists analyze the atmospheric composition of exoplanets to assess the likelihood of liquid water existing. High levels of water vapor in the atmosphere suggest a higher probability of liquid water. Additionally, the measurement of the amount of energy received from the exoplanet's host star helps estimate surface temperatures. Factors like greenhouse effects can influence temperature regulation. To confirm the presence of an atmosphere, scientists examine the spectra of exoplanets and estimate atmospheric mass by measuring the planet's mass. The relative proportions of elements released by the host star are analyzed to evaluate the availability of essential elements. Further analysis of the composition of the planet's surface and geology can provide insights into the presence of necessary elements. The search for exoplanets that meet all of these conditions is challenging, but ongoing efforts by scientists have led to the discovery of numerous exoplanets that increasingly resemble Earth conditions. As a result, the possibility of life existing on exoplanets is becoming more promising.
The discovery of exoplanets. Exoplanets, or planets beyond Earth, are very likely to exist in the universe. In fact, many astronomers are working to find exoplanets. The James Webb Space Telescope observed the TRAPPIST-1 system, which is 40 light-years from Earth, and found that 7 of the planets have the potential to support life. The planets in the TRAPPIST-1 system are all similar in size to Earth, and their orbital periods around the Sun are also similar to Earth's. What is TRAPPIST-1? How did the James Webb Space Telescope discover exoplanets? What is the significance of this discovery for the possibility of extraterrestrial life? Earth, where we live, is a planet orbiting the Sun. It is highly likely that there are many planets with conditions similar to Earth in the universe. The James Webb Space Telescope observed the TRAPPIST-1 system, which is 40 light-years from Earth. The TRAPPIST-1 system is a star system with 7 planets of similar size to Earth orbiting the Sun. This discovery is a major boost to the expectation of the existence of exoplanets. The planets in the TRAPPIST-1 system are all similar in size to Earth, and their orbital periods around the Sun are also similar to Earth's. Therefore, it is possible that some of these planets support life. What is TRAPPIST-1? TRAPPIST-1 is an ultra-cool dwarf star located about 40 light-years from Earth. It has 7 planets orbiting it, 5 of which are roughly the size of Earth. How did the James Webb Space Telescope discover exoplanets? The James Webb Space Telescope is an infrared telescope. Infrared light has a longer wavelength than visible light, so it can penetrate through dust and gas to observe exoplanets that would otherwise be hidden. The James Webb Space Telescope observed the TRAPPIST-1 system and analyzed the atmospheres of the 7 planets. It found that all 7 planets have atmospheres similar to Earth's. What is the significance of this discovery for the possibility of extraterrestrial life? Planets with atmospheres similar to Earth's are more likely to harbor life. Therefore, the discovery of the TRAPPIST-1 system is a major boost to the hope of finding extraterrestrial life.
Title: Proxima b, a habitable zone Earth mass exoplanet orbiting Proxima Centauri. Authors: Guillaume Anglada Escudé, et al. Publication date: August 24, 2016. Summary: on August 24, 2016, Guillaume Anglada Escudé and his colleagues announced the discovery of a new planet orbiting a red dwarf star called Proxima Centauri. The planet, named Proxima b, has a similar size and mass to Earth. Proxima b is located about 0.05 light-years away from Proxima Centauri and has an orbital period of about 11.2 days. Proxima b is a new candidate for hosting life. Proxima b is situated at a suitable distance from Proxima Centauri and is estimated to maintain a suitable temperature. Moreover, Proxima b has a possibility of having an atmosphere that could provide a habitable environment for life. The discovery of Proxima b raised the possibility of life in our galaxy. Proxima b is one of the closest exoplanets to Earth and a new candidate for hosting life. The study of Proxima b will play an important role in revealing whether life exists in our galaxy or not. Introduction: Proxima Centauri is the closest star to our solar system. Proxima Centauri is a red dwarf star with about 1/8 of the mass of Earth. Proxima Centauri is a very dim star that cannot be seen from Earth. The existence of planets orbiting Proxima Centauri has been proposed for a long time. However, it was very difficult to observe planets orbiting Proxima Centauri directly. This is because Proxima Centauri is a very dim star and the light of the planets is obscured by the light of the star. Evidence: Anglada Escudé and his colleagues succeeded in observing a planet orbiting Proxima Centauri directly. They analyzed the light of Proxima Centauri and found tiny traces caused by the gravity of the planet. They were able to confirm the existence of Proxima b through these traces. Proxima b has a similar size and mass to Earth. The mass of Proxima b is about 1.3 times that of Earth and the radius is about 1.1 times that of Earth. Proxima b is located about 0.05 light-years away from Proxima Centauri and has an orbital period of about 11.2 days. Conclusion: the discovery of Proxima b raised the possibility of life in our galaxy. Proxima b is one of the closest exoplanets to Earth and a new candidate for hosting life. The study of Proxima b will play an important role in revealing whether life exists in our galaxy or not.
Title: James Webb Telescope hunts clues of extraterrestrial life. Introduction. Hello, everyone. Today, let's discuss the news about the James Webb Space Telescope detecting traces of extraterrestrial life on distant planets. Main body. The James Webb Space Telescope is the state-of-the-art space observatory launched by NASA in December 2021. This telescope boasts significantly enhanced capabilities compared to its predecessor, the Hubble Space Telescope, revolutionizing space exploration. In September, the James Webb Telescope observed the atmosphere of an exoplanet named K218b, located approximately 120 light-years away from Earth. The telescope discovered dimethyl sulfide, DMS, molecules in the planet's atmosphere. DMS is a substance primarily produced by living organisms on Earth, indicating the potential existence of life forms. Furthermore, the James Webb Telescope detected methane and carbon dioxide in the atmosphere of K218b. The presence of these gases suggests the possibility of oceans made of water existing on this planet. The research team expressed shock at these findings and emphasized the need for further data verification. However, this discovery marks a significant moment in space exploration. It opens possibilities for discovering more traces of life in the future. Another exoplanet discovery. The James Webb Telescope also made intriguing discoveries on another exoplanet, WASP 107b. This planet, larger than Neptune, is located around 200 light-years away from Earth. The telescope captured clouds consisting of water vapor, sulfur dioxide, and sand in the atmosphere of WASP 107b. This marks the first instance of clouds being observed in the atmosphere of an exoplanet, contributing to a better understanding of exoplanetary atmospheres. Conclusion. The news of the James Webb Space Telescope discovering traces of extraterrestrial life has heightened expectations for space exploration. The anticipation grows to observe more signs of life through the observations of the James Webb Telescope in the future. How does the James Webb Space Telescope observe exoplanet atmospheres? The James Webb Space Telescope observes exoplanet atmospheres using near-infrared and mid-infrared wavelengths. These wavelengths are much longer than visible light, making them suitable for observing the light absorbed by the atmospheres of planets. The telescope is equipped with 4 major observational instruments. Among these, the near-infrared spectrograph, NIRSpec, uses near-infrared wavelengths to observe the spectrum of light absorbed in the atmospheres of exoplanets. A spectrum is a graph that shows variations in intensity based on the wavelength of light. Absorption lines indicate where specific wavelengths of light have been absorbed in the atmosphere. The Mid-Infrared Instrument, MIRI, of the James Webb Telescope uses mid-infrared wavelengths to observe the spectrum of light absorbed in exoplanet atmospheres. MIRI provides higher resolution compared to NIRSpec, allowing for more detailed information retrieval. The Near-Infrared Camera, NIRCam, captures images of exoplanets using near-infrared wavelengths. These images help in understanding the structure of exoplanet atmospheres and the presence of clouds. The Mid-Infrared Camera, MIRI, of the James Webb Telescope also captures images of exoplanets using mid-infrared wavelengths. MIRI, with its higher resolution compared to NIRCam, provides more detailed information. Through these observational instruments, the James Webb Space Telescope can determine the types and quantities of substances present in exoplanet atmospheres, their atmospheric structures, and the presence of clouds. Such information aids in identifying environments on exoplanets that could potentially harbor life forms. What kind of substance is DMS, and why does it suggest the existence of life? DMS, short for dimethyl sulfide, is a compound formed by the combination of methane and hydrogen sulfide. On Earth, DMS is primarily produced by marine microorganisms. Marine microorganisms utilize hydrogen sulfide to obtain energy, releasing DMS as a byproduct. DMS plays a crucial role in Earth's atmosphere. It contributes to ozone layer protection, alleviates climate change, and promotes cloud formation. DMS has also been discovered on planets beyond Earth. In 2021, the James Webb Space Telescope detected DMS in the atmosphere of an exoplanet named K218b, situated approximately 120 light-years away from Earth. This discovery hints at the potential presence of life on K218b. Here are reasons why DMS suggests the existence of life. 1. On Earth, DMS is predominantly produced by living organisms. Hence, if DMS is found on an exoplanet, it might raise the possibility of the existence of life forms. 2. DMs plays a significant role in Earth's atmosphere, indicating that an exoplanet with DMs might possess an environment conducive to sustaining life forms. However, it's crucial to note that the presence of DMs alone doesn't definitively prove the existence of life. DMs can be produced by abiotic processes on planets beyond Earth, such as volcanic activity or collisions of celestial bodies. Therefore, it is essential to further observe the atmosphere of K218b in detail using the James Webb Space Telescope to verify whether DMs has been generated by living organisms or through non-biological processes. How do methane and carbon dioxide affect the existence of extraterrestrial life? Methane and carbon dioxide are both gases that play crucial roles in creating environments conducive to sustaining life forms. Methane can serve as an energy source for life forms. On Earth, methane is primarily generated by anaerobic microorganisms. Anaerobic microbes create methane in environments lacking oxygen to obtain energy. Carbon dioxide is essential for photosynthesis in plants. Plants utilize carbon dioxide to produce oxygen and glucose through photosynthesis. Glucose serves as an energy source for plants. Therefore, if methane and carbon dioxide are discovered on an exoplanet, there is a higher likelihood that the planet possesses an environment suitable for sustaining life forms. Here is the specific impact of methane and carbon dioxide on the existence of extraterrestrial life. Impact of methane. Methane can be used as an energy source for life forms, primarily generated by anaerobic microorganisms. Therefore, the presence of methane on an exoplanet indicates a higher possibility of anaerobic microorganisms or similar life forms. Methane can influence climate change. It is known to cause climate change approximately 25 times faster than carbon dioxide. Hence, discovering methane on an exoplanet suggests a higher likelihood of significant climate changes on that planet. Impact of carbon dioxide. Carbon dioxide is essential for photosynthesis in plants. Its presence on an exoplanet suggests a higher possibility of plant life. Carbon dioxide can also impact climate change by raising atmospheric temperatures. Thus, finding carbon dioxide on an exoplanet implies a higher likelihood of significant climate changes on that planet. In conclusion, methane and carbon dioxide serve as important indicators hinting at the existence of extraterrestrial life. However, since these gases can also be produced through non-biological processes, further detailed research is necessary to conclusively confirm the existence of extraterrestrial life.
Recently, numerous exoplanets with conditions similar to Earth have been discovered. Here are 10 of such recently discovered Earth-like exoplanets. The scientific evidence for these planets is as follows. 1. Orbital period. Planets orbit their stars at regular intervals, determined by the planet's mass and the star's mass. Measuring the orbital period allows for the estimation of the planet's mass. 2. Mass. A planet's mass influences its size and gravitational characteristics. Measuring the planet's mass helps estimate its size. 3. Radius. A planet's radius affects its surface temperature and the presence of an atmosphere. Measuring the radius helps estimate surface conditions and atmospheric composition. 4. Atmosphere. A planet's atmosphere shields its surface and may provide the oxygen necessary for potential life. Analyzing a planet's atmosphere helps assess the possibility of life. Using this scientific evidence, scientists estimate that these planets possess conditions similar to Earth. However, it is important to note that the actual presence of life on these planets has not been confirmed. Nevertheless, the discovery of these planets increases the likelihood of extraterrestrial life. Furthermore, recent advancements in technology have enabled the direct observation of exoplanet atmospheres. With these techniques, scientists can measure the types and quantities of gases present in exoplanet atmospheres more accurately. Therefore, in the future, the evaluation of the potential for life on exoplanets is expected to become even more precise. The 10 exoplanets listed in the table above have the following characteristics. Mass. 1.1 to 1.7 times that of Earth, with a size similar to Earth. Radius. 1.1 times that of Earth, with a surface temperature similar to that of Earth. Atmosphere. Possible existence, but not yet directly observed. Location. Located in our galaxy, with the distance from Earth known for some planets as follows. Kepler 186f. The closest exoplanet to Earth in our galaxy, at a distance of about 49 light-years from Earth. Kepler 1649c. The exoplanet most similar to Earth in our galaxy, at a distance of about 300 light-years from Earth. TRAPPIST-1d, at a distance of about 40 light-years from Earth. Gliese 832c, at a distance of about 16 light-years from Earth. Proxima Centauri b, an exoplanet orbiting the nearest star to the Sun in our galaxy, Proxima Centauri, at a distance of about 4.2 light-years from Earth. Ross 128b, at a distance of about 11 light-years from Earth. LHS 1140b, at a distance of about 40 light-years from Earth. HD 106906b, at a distance of about 39 light-years from Earth. TOI 700d, at a distance of about 100 light-years from Earth. These exoplanets are all located in the habitable zone of our galaxy. Therefore, it can be said that there is a very high possibility of life on these planets. Scientists use a variety of methods to explore these exoplanets. The most common method is to observe the slight change in the brightness of a star due to the gravity of a planet. Through this method, scientists can confirm the existence of a planet, estimate its orbital period, mass, and radius. Recently, the technology for directly observing the atmospheres of exoplanets has also been developed. Through this technology, scientists can measure the types and quantities of gases present in the atmospheres of exoplanets. Therefore, it is expected that the possibility of life on exoplanets can be more accurately assessed in the future. The discovery of these exoplanets opens up new possibilities for the exploration of extraterrestrial life. It is expected that more information about the possibility of life on exoplanets can be obtained through the continuous research of scientists in the future. Proxima Centauri b is a member of the Alpha Centauri triple star system, at a distance of about 4.2 light-years from Earth. The Alpha Centauri triple star system is part of our galaxy. Therefore, Proxima Centauri b can be considered an exoplanet in our galaxy. However, the Alpha Centauri triple star system is located at a distance of about 26,000 light-years from the center of our galaxy. Therefore, Proxima Centauri b can be considered one of the most distant exoplanets from the center of our galaxy. Therefore, Proxima Centauri b can be classified as an exoplanet in our galaxy or an exoplanet in the Alpha Centauri system. Both classifications are correct.
Enceladus, a small moon of Saturn, possibility of extraterrestrial life. Hello everyone. Today, I would like to introduce Enceladus, one of Saturn's small moons, and discuss its potential for extraterrestrial life. Despite its small size with a diameter of only 504 kilometers, Enceladus provides crucial clues suggesting the possibility of extraterrestrial life. Enceladus, a moon of Saturn, is the 14th moon from the planet and orbits within Saturn's E ring. It was discovered in 1789 by William Herschel and is named after Enceladus, a giant in Greek mythology. Enceladus has geysers that spray material from its south pole, and there is evidence that it may have an ocean beneath its surface. Enceladus is considered an important body for astrobiology research, and it is a tiny satellite with a diameter of only 504 kilometers, making it less than 1/10 the size of Titan, Saturn's largest moon. The surface of Enceladus is covered with clean ice with minimal impurities, resulting in a very high reflectivity of approximately 0.81 plus or minus 0.04. This high reflectivity makes it relatively bright and easy to observe. The average temperature on the moon is minus 198 degrees Celsius. One of the most significant features of Enceladus is the south polar terrain, characterized by two massive fissures known as the Southern Rift Valley. These fissures extend up to 100 kilometers in length and 5 kilometers in width, with a central mountain range reaching a height of 10 kilometers. The south polar terrain of Enceladus shares similarities with Earth's volcanoes. Water erupting from the central part of these fissures is composed of ice, and the ejected material breaks through the icy crust covering the moon's surface, spewing into space. This ejected material is known as Enceladus plumes. The existence of plumes on Enceladus is a crucial clue suggesting the potential for extraterrestrial life. The subsurface ocean within Enceladus provides an environment conducive to the existence of life forms. The ocean water is rich in nutrients and energy sources, maintaining a stable temperature. Moreover, the ocean water contains chemical compounds that promote the synthesis of organic molecules. Its surface is covered with clean ice with minimal impurities, resulting in a high reflectivity of about 0.81 plus or minus 0.04. This makes Enceladus relatively bright and easily observable. The moon's average temperature is minus 198 degrees Celsius. The most notable feature of Enceladus is the south polar terrain, specifically the southern Rift Valley, which consists of two large fissures measuring 100 kilometers in length and 5 kilometers in width. The central parts of these fissures feature mountain ranges reaching heights of 10 kilometers. The south polar terrain of Enceladus shares similarities with Earth's volcanoes. The water erupting from the central parts of these fissures is composed of ice, and the material flowing from the fissures punctures through the icy crust covering the Moon's surface, erupting into space. These eruptions are known as Enceladus geysers. The geysers of Enceladus provide important clues regarding the potential for extraterrestrial life. The subsurface ocean within Enceladus offers an environment suitable for the existence of life. The ocean water is rich in nutrients and energy sources while maintaining a stable temperature. Additionally, the ocean water contains chemical substances that can facilitate the synthesis of organic molecules. NASA's Cassini spacecraft extensively observed Enceladus from 2005 to 2017, making 22 close flybys. Cassini's observations revealed that the water erupting from the south polar terrain of Enceladus contains both organic and inorganic materials. This discovery strongly suggests the possibility of life within Enceladus. Enceladus is a key target in the search for extraterrestrial life. NASA is developing the OSIRIS-REx spacecraft, targeting a launch in 2025, to explore Enceladus. OSIRIS-REx will collect samples of water and soil from the south polar terrain of Enceladus and bring them back to Earth for analysis. Scientists aim to determine whether life may have existed within Enceladus based on the analysis of these samples. The OSIRIS-REx spacecraft is part of NASA's New Frontiers program and is scheduled to be launched on September 25, 2025. The spacecraft will arrive at Enceladus in 2029 and conduct exploration activities until December 31, 2031. Upon reaching Enceladus, the spacecraft will use a sample collection device to gather water and soil from the Moon's south polar terrain. The collected samples will be stored in the spacecraft's capsule and are planned to return to Earth by December 2033. The launch schedule for the OSIRIS-REx spacecraft is as follows. September 25, 2025, launched from Cape Canaveral Air Force Station in Florida aboard an Atlas V rocket. October 20, 2026, adjusts orbit through a close flyby of Mars. October 24, 2027, modifies orbit through a close flyby of Earth. October 25, 2028, arrives at Saturn. January 27, 2029, enters orbit around Enceladus. December 28, 2031, begins sample collection at Enceladus south polar terrain. December 19, 2033, enters orbit for the return to Earth. December 21, 2033, enters Earth's atmosphere. December 23, 2033, lands on Earth. The successful launch and exploration activities of the OSIRIS-REx spacecraft are expected to contribute significantly to understanding the potential existence of life within Enceladus. Importance of Enceladus exploration. Enceladus is a crucial target in the search for extraterrestrial life. The subsurface ocean within Enceladus is rich in nutrients, energy sources, and maintains a stable temperature, creating a suitable environment for potential life forms. Additionally, the ocean water contains chemical substances that can facilitate the synthesis of organic molecules.